Welcome to Pre-Calculus and the Flipped Classroom. We're going to start right off in the beginning with Chapter 1.1, the topic being graphs of equations. We're also going to be focusing on circles in this section, so, can't spell, circles. This is a flipped classroom, so you can watch this video as much as you want, and that is the beauty of the flipped classroom. When you walk away from this chapter or from this section, what you're going to want to feel comfortable doing are these three objectives here. So I highly suggest revisiting these objectives and then just making sure that you feel comfortable after watching this video collecting solution points, so knowing what those are, and then with those solution points you're able to sketch graphs. The other thing is you're going to have to define what models exactly are to us in mathematics. So what is that word? And then also know how to graph circle equations. This is huge. Okay, circle equations is a big thing that you'll need to recognize. We're going to start off with this particular equation. This is from a Wired magazine, and what this demonstrates to us, or what this portrays or models to us, is phantom traffic. What is phantom traffic, you may ask? That's that scenario where you're traveling down the freeway and everything starts to slow down. It's like a traffic jam. And you're thinking to yourself, if you're a rager, how angry you are that there's a traffic jam. Or if you're a more reasonable person, you're thinking, man, I hope everything's okay up there. I hope that there's no accident. People are all right. So you're traveling along this traffic jam at snail's pace, and then all of a sudden, you're looking around and you speed up. You're just like, what the heck? Nothing happened. Nothing happened. That's phantom traffic. So this idea of a traffic jam, but there was really no reason for it. So you can look at this type of equation. Someone put this together with all the different type of unknowns. They recognize patterns, somehow put this together, and then they've identified what are all these variables or all these factors that were part of what makes phantom traffic. All right, so there you have it. So we're not going to focus on equations of that complexity, but what you will see here are some vocabulary. We're going to go ahead and pause me at this point and write these in your notes. Feel free to, abbreviate however you want. But I pause me because I'm just going to keep talking here. Some key things that you want to know about these are equations in two variables. What we are going to be doing mostly in the whole pre-calculus is focusing on equations of two variables. Okay, so you're going to have an x and a y, or a t related to maybe s, something like that. Solution point, what we're really looking for is when you're studying a particular equation, what are those two variables, what's those pairs that make that particular equation of study true. And then finally, when you collect all of these true solution points, that's going to be creating what we call a graph, so some sort of visual model. So it's the set of all, I should say, solution points, or in other words, the set of all points that are solutions to an equation. Oops, it's a collection of solution points. Alright, so we're going to do an example of this whole solution points, collecting these solution points and graphing from them, because again, one of our objectives is to graph equations, no matter what they are. So some of you might recognize this equation, but if you don't, what we are going to resort to is doing an XY table, finding the solutions, and then plotting them. If you're laughing right now that I'm making you plot, you shouldn't laugh, because really what plotting is, these XY tables, they're really a crutch, and you shouldn't laugh at crutches because they help people. So this right here, again, you might know what it looks like. Eventually we're going to get into more complex graphs, and when we do, that's when these XY tables are going to be a huge help. So you're going to want to make sure that you embrace the simplicity of it at the moment, because it will help you in the future. So I'm going to go ahead and start doing some of these. If I chose x to be 0, again, we call this the independent. We can let x be anything, but then if you let x be 0, y is going to have to follow suit as -4 when you simplify that side out. So this right here is going to be one of our solution points. Likewise, if I chose, let's say, 0.01, you can either plug it into your calculator or simplify it out. That's going to be the y value that goes with that particular x. And again, here's your solution point, or your coordinate pair. Okay, so what you can see here is I can go ahead and start plotting these. I have a 0, -4. I have a 0.1, which is hardly over, and then this, which is hardly down. Okay, so what's happening here is I am starting to get, there's an infinite amount of points. I'm going to do one more here. If you did 0.5 squared minus 4 is going to be -3.75. So there I could do another one. I'm going to be around about here. Okay, and then let's say I did one more here. Let's plug in, let's say 2. And then you would get 2 squared minus 4 is 0, so 2, 0. So here's that side of it. You might be recognizing this shape at this point. Note how I've only kind of done one side. What happens if you go on that side? You're going to want to finish this up in your notes. So please do that. Alright, so equations. We're learning what are solutions, how do you graph these equations. One of your other objectives was to recognize the word models. So again, models are just things that represent or display some sort of data to people. So this, for example, is an equation that is a model. All right, this is the graph of that equation. If you were to go ahead and build up an XY table, which I could do here, that XY table is also a model. That's displaying this data, it's displaying information. So all three of these, and actually even a map displays information, that is also a model. And then we also have other types of models as well. So I don't know that they really display, data, but what they do is display or kind of create an image for society. So here we have these different things of models. What this model actually does represent is the conversion of Fahrenheit to Celsius. So just an interesting fact, one of the hottest recorded places was in Death Valley in California, and the temperature got up to 129.2 degrees Fahrenheit. So if you were to go ahead and then relate this, I did give you the F, or the dependent variable, instead of the independent, so you'd have to finagle this a bit to get your C, but eventually you would get 54. So there is your solution point, and you could also go over 54 up 129.2, and that would be one of those solution points that you had. Okay, so anything, keep in mind though, obviously not everywhere gets this hot, so the idea would be that, hey, maybe you only wanted to, by the way, I probably should have labeled these. This is the Celsius, this is the Fahrenheit. So if, let's say, someone else in the world, because everyone pretty much uses Celsius instead of Fahrenheit, let's say that it was like 30 degrees Celsius, and you wanted to figure out what the Fahrenheit was, you could use a model like this equation and figure that it's about 82 maybe degrees Fahrenheit, or you could use the equation to figure it out, or if there was a table that displayed all that data, you could use that. Alright, so the next thing, now that we've discussed those first two objectives there, we're going to move on into recognizing the circle equation. So this right here is the circle equation. Note that if you do, let's say, publish some sort of equation out there that you want to make usable to other people, there's going to be a whole lot of variables, just like that phantom traffic one, and you have to identify what those variables are. Now keep in mind, these equations were created by somebody, so they could use whatever variables they wanted to represent those numbers. So here, what I want you to recognize is the circle equation is a chunk squared plus a chunk squared equals a number. And particularly, that number squared is going to be the radius. So that's what this first thing is going to be standing for. Whatever that number was, if you square root it, that's going to be your radius. So these h and k's are always going to be filled in on your circle equation. That h and k is going to have to be fixed for a particular circle. This radius is going to have to be fixed, and that is what forms when you know a center, where that circle is, and when you know that the radius is a certain distance all the way around that center, that's what creates a collection of points that form a circle. So this right here is again going to have an h, k, so a center, and a radius that will define a circle equation. So a chunk squared plus a chunk squared equals a number. With those three things filled in, that's going to be what you recognize as a circle model. So This down here is just this slightly modified. If you square rooted both sides, you're going to get the radius by itself. Keep in mind whenever you square root something, you have a plus minus, right? Don't forget that. But oftentimes you won't see that plus minus because technically if you are solving for a radius and you know that the radius is a distance, then it couldn't be negative. But we will discuss this a little bit further when we talk about using our graphing calculators and actually graphing a circle. Alright, again I mentioned someone created these and they used the variables that they wanted to. So those are bound to change as you go from one published equation to another, depending on whoever is publishing them. So you again just have to have that type of key that's going to communicate to people what your variables stand for. So it doesn't matter what you use, just know again that you would have a radius, and this second part is going to have to be defined as your center. Alright, so write the standard form of the equation of the specified circle, center being 0, 1, and a solution point being 0, 5. So we have to fill this in. Again, this has to be fixed, this has to be fixed, and this has to be fixed in order for us to have a true model that's an equation of a circle. So let's go ahead and fill in. We know that the center is at 0, 1. So I'm going to start drawing a picture here. We also know a solution point, a point that makes this equation true, is going to be 0, 5. So this is one of our solution points, right? So we're going to go ahead and fill in, because it was specified that that other x, y value in those chunks is going to be a solution point. So again, that's going back to this right here, that knowing that x and y in our equation was a solution point or one of those true values in that equation, so therefore making up that graph. Alright, so now filling in our solution point here, 0, 5, so we have our center, solution point, center, xy value of the center, xy value of our solution point given by what that equation states. Now we could solve for this r, which stands for our radius. So if you took r is equal to, and then the square root of, I'm going to simplify 0 minus 0 is just 0 squared, so 0, plus, and then we have 5 minus 1 squared, which is going to be 4 squared. We have r is equal to the square root of 4 squared, which the square root undoes a power of 2, so r is simply equal to 4. So looking at this, hopefully you could have told that right off the bat by just counting, that we have the distance from the center to one of the solution points, which is one of those pieces on the graphs, that graph, it's going to be a radius of 4. Alright, so now we need to write the standard form equation. Keep in mind, this is not the only the solution point that would have worked. So we could have had like -1 and 1 also be put into this equation that would make this equation true, right? So it's these really that vary. Depending on like what you put in for this is going to be very directly related to it in order to make a true statement. So here we have some other ones. And then there's a bunch of really weird decimals, some irrational, that are going to be forming that circle. So the idea would be, though, going back to what the question asks, write the standard form of the equation. That standard form was r squared equals, and then we had a chunk squared plus a chunk squared, h, k is what we said for the center. So we said the center has to be filled in, and same with the radius. We know what the radius of this circle is now that we had solved for it. So it's 4 squared equals x minus, this is what we have to fill in, we have to fix that center. It was at 0, 1, so the x value of the center was 0 squared plus y minus 1 squared. So our final answer is all simplified out is going to be 6, and this right here would be a standard form equation of a circle. You would recognize this right off the bat as a circle, and then you could figure out from it what is the center, what is the radius. Alright, so this one I am going to not do all the way. It's a little bit trickier, but what I am going to do is draw a sketch for you to tell you exactly what's going on, and then we'll try to brainstorm up ideas as we work together in class to do these tomorrow. So we're over, I'm going to draw my arrow down here, sorry. There's my x-axis, disregard that. So we will go over 6, 1, 2, 3, 4, 5, 6, up 1, 2, 3, 4, 5, 6, 7, 8. There's a solution point, and then, actually, endpoints of a diameter. We know that we're looking at, if you were to look at a circle, a diameter is something that goes through the center, right, and then connects on 2 points of the circle. So I know that this must be a solution because it's on the circle. All right, this then has to be the other point. It's at 0, 0. So this right here is a diameter. So if I were to do the best circle I could to model what's going on here, it would look something like that. So now how are we going to come up with the equation of a circle? If you need to, I would kind of list out what do you know, what don't you know, and what do you need to find here, and see if you can't come up with the best way to figuring out the standard form of that equation. Alright, and finally this example, what we need to do is kind of go backwards. Instead they gave us the equation, the standard form equation. It's a chunk squared plus a chunk squared equals a number, which that number is a radius squared. So we're going to have to sketch this. So if you were to match this up to that type of standard form equation, you can now just kind of go in and say, alright, it was x minus what? Well, in this case we were subtracting nothing, which 0 represents that nothing. So our h is going to have to be 0. Oh, I'm sorry, this was supposed to be k, but it was 0. Alright, so our center is 0, 0. That's that h, k. And then this part right here, we see that 16, so r squared was equal to 16, it appears. So if you are going to solve for r, then you can square root both sides. Technically, to get rid of that, you would have a plus minus, but we know it's positive, so it's going to be 4. Radius is equal to 4. So now if you were to go ahead and sketch this, we have a center at 0, 0. You want to always draw those nice solid 4 points that are directly to the left, directly to the right of our center, and then up and down from it. So there's our 4, there's our 4, and then you're going to do the best you can to represent those kind of oddball solutions that would be ugly decimals. There we go. Here are your practice problems. We will work on these in class, and do note that for 76 you don't need your graphing calculator, even though the directions in your book say that you need to use one. Alright, good luck.